All right, what I want to do here is do some examples of how we can do some of these calculations within Excel. So what I'm going to do here is in Excel, I'm going to look at how we can use a factorial. So what's nice about Excel, so here we're looking for the number of permutations that are in a 9x9 Sudoku puzzle. So how many different ways can we do the first row? And so there's permutations of 9, that there are 9 numbers that can go in there, and we have the counting rule that comes into play. So if I switch over to Excel here, oops, let me close this, go back, sorry, and let me increase my view here so that we can see what I'm typing. If I want to do any factorial, I have the FACT command. And so factorial 9 does the calculation for me here. And we should see that that is the same as what we would get from a calculator. So we have the ability to do factorial calculations, but we can also do permutations. So this permutation, you don't have to create a formula in Excel using the factorial command. What you can do is you can use the permutation command in Excel. So I think I'm going to look at the permutations of how many race cars can, how many different ways cars can finish first, second, and third using permutations. So there's 33 race cars, and we want 3. So what I'm going to do here is I'm going to come back over to Excel. And I have my factorial command here. What I'm going to do is say I have 33 cars. I'm going to pick 3 of them. So my permutations. And I'm going to use the command here, equals. And I'm going to type in permutation, or PUMT. And notice that it wants the number n. So it asks for n first. So in this case, I put that in E2. And then it wants the number chosen. And so that's E3. And it does the permutation calculation for us. So we have these functions built into Excel. So I'm looking at the different examples that we have. So if we come back to the example we were looking at, and we have 33 race cars, and we need first, second, and third. So we have n number of objects, and we're picking 3 of them. And so our function within Excel does the calculation for us. Whoops. Quickly and efficiently by using our Excel commands. Now, distinguishable permutations, when we have a different choice of objects coming across, we have to build this formula in Excel. And what we can do is we can keep track of, we know n is a total of all of the objects. And so I can keep track of n1, n2, n3, all the way up to k, and get a sum of n, and then build this formula, n factorial divided by the factorials multiplied. Whoops, didn't mean to do that. The factorials multiplied of all of the other objects. So if we look at the example, oops, that's the wrong example, distinguishable permutations. Here we go. Yeah, the building contractor wants to do a subdivision of 6 one-story houses, 4 two-story houses, and 2 split levels. So I have n1 equals 6, n2 equals 4, and n3 equals 2. And if I add those up, my total n is 12. But we want Excel to do the work for us. So I'm going to come over here, and I'm going to do this problem. I'll say that n1 equals 6, n2 equals 4, and n3 was 2. And instead of summing these individually and going 6 plus 4 is 10 and 10 plus 2 is 12, I can do the sum of C6 6, which is my first cell, to C8. And so there I get my N total. And then in my distinguishable permutations, I have to build the formula into it. So upstairs, I'm going to have N total factorial. So I need to use the factorial command. And in the parentheses, I'm going to put my total, which was C9. And I'm going to divide it by a multiplication, but this multiplication has to be in parentheses. And so it's going to be the factorial of N1, which is C6. And then I'm going to multiply that by the factorial of C7. And then I'm going to multiply that by the factorial of C8. And I'm going to close out my parentheses for the division. I need this parentheses in the bottom here so that it does all these multiplications before doing the division. And I get the answer that I would have gotten using the TI-84 or any other technology. And so Excel as a calculator works really nicely to us. There's one other example to do here. And that's combinations. Combinations with the NCR command. And so the number of objects, and then in how many we're picking, but order doesn't matter. And so what's nice is if I use this example, where I have 16 bids and 4 are going to be chosen, but order doesn't matter, well, I'll come back over to Excel. And I will say for this one, and we have 16 contractors and 4 bids are going to be chosen, but it doesn't matter the order. And so I can start typing in combination, and notice we have the combin command, and it wants the same thing. It wants the number to pick from. And so what cell is that in? That's E11. And then in the number we're choosing, which is E12. And we do the combination commands. So for these larger calculations, Excel does have built-in commands that make it easier for us. And as I was telling students in my in-person class, that if you forget a command, a lot of the times if you start typing the word for the command, that's usually the thing Excel calls it. So factorial is F-A-C-T, permutations is P-U-R-M-U-T, and combinations is C-O-M-B-I-N. The only thing we don't have is a formula for distinguishable permutations, unless they've added one since I've last checked in Excel. But these tools will help us.